Our universe is a vast and mysterious place. It's filled with billions of galaxies, each containing billions of stars. But have you ever wondered where it all began? The prevailing scientific theory is the Big Bang. It's the idea that the universe as we know it started from an extremely hot, dense state. Picture a tiny speck smaller than an atom containing all the energy and matter that would become everything we see today. This wasn't an explosion in the traditional sense, like a firework going off in space. Instead, the Big Bang represents the expansion of space itself. Imagine a balloon with dots drawn on it. As you inflate the balloon, the dots move further apart, just like galaxies in our expanding universe. This expansion continues even today, billions of years later. The Big Bang theory is a cornerstone of modern cosmology. It helps us understand the evolution of the universe from that initial state of extreme density to the magnificent structures we observe today. But getting to this understanding was a journey in itself, with scientists first having to challenge long-held beliefs about the nature of the cosmos. For centuries, the idea of an eternal and infinite universe held sway. This view, often called the steady-state theory, proposed that the universe had always existed, unchanging and everlasting. It was a comforting thought, a universe without a beginning or an end. This view of the universe was deeply ingrained, supported by philosophical and religious ideas. It seemed intuitive, even obvious, that the universe had always been as it was. However, the seeds of doubt were sown as new scientific tools and theories emerged, allowing us to probe the cosmos in ways never before possible. The development of powerful telescopes in the early 20th century allowed astronomers to peer deeper into space. They observed distant galaxies, faint smudges of light from incredibly far away. These observations, coupled with groundbreaking theoretical work, would soon challenge the very foundations of our understanding of the universe. In 1915, Albert Einstein published his groundbreaking theory of general relativity. This revolutionary theory described gravity not as a force, but as a curvature of spacetime caused by mass and energy. Einstein's equations initially suggested that the universe should be either expanding or contracting, a dynamic universe rather than a static one. Around the same time, astronomer Edwin Hubble was making groundbreaking observations at the Mount Wilson Observatory in California. Using a powerful new telescope, Hubble observed that galaxies were not fixed in space. Instead, they were moving away from us, and the farther away a galaxy was, the faster it seemed to recede. Hubble's observations, combined with Einstein's theory, pointed towards a startling conclusion. The universe was expanding. This discovery shattered the long-held belief in a static universe, paving the way for a new understanding of the cosmos and its origins. Section 4. Echoes of the Big Bang. If the universe is expanding, it stands to reason that it was once much smaller and denser. This realization led physicists to propose the Big Bang theory, a model where the universe originated from an extremely hot, dense state. But how do you prove something as monumental as the birth of the universe? The answer came in 1964 when Arno Penzias and Robert Wilson, two radio astronomers at Bell Telephone Laboratories, stumbled upon a faint, persistent hum in their antenna. This hum, they soon realized, was not from any earthly source but came from every direction in space. It was cosmic microwave background radiation, the faint afterglow of the Big Bang itself. This discovery was a turning point, providing the most compelling evidence yet for the Big Bang theory. The cosmic microwave background radiation is essentially a snapshot of the universe just 380,000 years after the Big Bang, a faint echo of that primordial event still reaching us across billions of years. Section 5. A universe stretching, not exploding. It's important to remember that the Big Bang wasn't an explosion in the traditional sense, like a bomb detonating. Instead, it was the expansion of space itself. Imagine a loaf of raisin bread dough rising in the oven. As the dough expands, the raisins within it move further apart. Similarly, in the Big Bang, space itself expanded, carrying galaxies along with it like raisins in the dough. This expansion continues today, stretching the very fabric of spacetime. This means that galaxies are not flying through space. Instead, space itself is expanding, increasing the distances between them. The Big Bang model doesn't tell us what, if anything, existed before this expansion. It simply describes the evolution of the universe from a very early, extremely hot and dense state, not an explosion in a pre-existing space.